A vault with 4,663 files with a brute force search took 15.6 seconds. Through Obsidian's own index, it took 0.26 seconds, around 60 times faster. Once you add links, the graph starts showing you the shape of the vault. This vault gave it my standing strategy, and the live data tested the idea, and it corrected the recommendation before I spent time writing the wrong thing. For a long time, I was my AI's memory. I would open ChatGPT, Claude, or one of my agents and remind it where to look, what I was working on, and what we had already decided. The tools had memory, but it worked like a running log. The newest things stayed near the top, and the older context kept sliding further away. So when I wanted one topic across my whole history, I still had to pull everything together myself. I could ask Claude to read every old file again, but that gets slow and expensive very quickly. I needed a connected place where my notes, decisions, research, and draft could stay together, and where Claude could follow those connections without starting over every single time. That place became Obsidian. Once I connected the vault to Claude, I could land on one idea and bring up everything tied to it. That was the day I stopped being the memory. If this is your first time here, hi, I am Jenny. I believe anyone can thrive with AI, not by mastering the tools, but by building real things with them. I write a weekly newsletter called Build to Launch, where we apply AI to practical building and finish something real every week. Obsidian is a free notes app. Every node is a plain Markdown file on your own computer. You can open the folder yourself, move the files, back them up, or read them in any text editor. The app has 3 basic pieces. The vault is the folder holding everything. Each node is one Markdown file, usually focused on one idea. Then the graph shows how those nodes connect. That plain file foundation matters once Claude enters the picture. Because Claude already reads Markdown well, you are giving it files in a format it already knows how to work with. The connections come from 2 built-in features. The first is a Wikilink. You type the name of another node inside double brackets, and Obsidian joins the 2 nodes. So a project node can point to a decision, that decision can point to the research behind it, and Claude can follow the same path later. The second is properties. These are fields at the top of a node. Things like status, source, project, date, or tags. To me, this is where a folder of writing starts behaving more like structured data. Claude can read those nodes itself, then use those fields to filter and sort across hundreds of nodes. Once you add links, the graph starts showing you the shape of the vault. Every node is a dot, and every link is a thread between 2 dots. When nothing is linked, the nodes look like dust. They are all present, but they are floating on their own. As links accumulate, clusters appear. You can see which topics keep connecting, where 2 projects overlap, and which nodes are sitting alone. And Claude can help create those links while it works, so you do not have to sit there connecting hundreds of files by hand. The speed difference is what matters to you. A developer tested Obsidian on a vault with 4,663 files, finding disconnected nodes with a brute force search took 15.6 seconds. Through Obsidian's own index, it took 0.26 seconds, around 60 times faster. Then think about the AI cost. If Claude had to read all of those files to run the same scan, it would take roughly 7 million tokens. Through the index, the lookup can be around 100. Same answer, around 70,000 times cheaper. Obsidian can do this because it reads the vault once and builds an in-memory index called the metadata cache. That index knows the links, tags, headings, and properties. After that, Claude can use the map of the vault instead of reopening every file for every question. Your notes remain plain Markdown files. The fast index sits on top of them. So that is the Obsidian side. Local files, explicit connections, and a fast index over everything. The next question is, what changes when Claude can read and write inside that structure? If you have built with Claude for a while, you have probably noticed how often the work ends up in Markdown. Instructions, project context, plans, notes, and handoff files all use the same format. Obsidian starts from that same foundation. It gives Claude readable files, a steady stream of source materials, a place to write memory back, and links it can follow when it needs more context. Put those together and the vault becomes the long-term memory layer. Claude becomes the part that reads the relevant pieces and reasons over them and adds the result back. That lines up with the way Claude already works. Markdown gives it clean text. Wikilinks give it paths between ideas. Properties and tags give it fields to filter, keeping one main idea in each note gives Claude a focused unit to work with instead of making it dig through one enormous document. There is no special database format for Claude to learn. It can open the same note you open, read the same fields you see, and follow the same links through the bar. The next part is capture, because the second brain can only work with what reaches it. My own ideas, meeting notes, book quotes, articles, and videos can all land in the same vault. Obsidian's web clipper handles a lot of the online material. I can save an article as clean Markdown or save a YouTube page in a stripped-down reading view. If I highlight a sentence, the saved highlight keeps a link back to the original spot, so the material I am already reading and watching becomes something Claude can use later. I do not have to remember which browser tab it comes from or copy it into a new chat when I need it. Reading is only half of it. Claude can write the result back into the vault. In a normal chat, I might work through a decision, close the tab, and then repeat part of that thinking a week later. With the vault connected, Claude can save the decision into the project note, link it to the related research, and leave it there for the next session. That creates a loop. Claude writes a better note, the better note gives the next session more context. The next answer gets sharper, and that answer can be saved too. After a few weeks of this, the vault feels different. It has the history of the work, and each new session can build from that history instead of rebuilding the same context. If you have a large vault, it does not mean Claude has to read everything from the get-go. Mine uses a small map first, usually a short index or hub file that says what exists and where it lives. Claude reads that map, chooses the relevant path, and follows the links only where it needs more detail. If I ask which context I have not followed up with, it can read the context index, open the relevant person notes, check the last contact dates, and answer from those files. The map gives it orientation. The vault gives it depth. The index makes following those links fast, even when the vault has thousands of notes. One of my main uses is asking a question across my entire history. I can ask, what did my vault say about SEO? Claude pulls from strategy documents, draft notes, Google Search Console data, and old decisions. It gives me the answer and shows me the file behind each part, so I can check where the information came from. Then I pushed on the answer. Claude suggested a new article about Claude projects, and I asked, but does my SEO demand that though? Instead of defending this idea, it checked my latest Google Search Console report. The report showed that an existing Claude Code project ideas article had dropped 493 clicks in 1 week. So Claude walked back the new article and pointed me to the page I already had to defend. This vault gave it my standing strategy, and the live data tested the idea, and it corrected the recommendation before I spent time writing the wrong thing. When I want the raw cluster instead, I search by tag. This command pulls all the MCP nodes across my articles, short-form posts, programs, and products. Of course, 428 nodes is still a lot to look at, so I asked Claude to turn that cluster into a Obsidian base. The structure was already in the nodes: status, category, date, tier, tags, and folder. Claude used those fields to build a sortable table in one pass. Now I can sort the MCP nodes by status, find stale drafts, filter by category, or decide which piece needs attention next. The nodes remain the source. The base is a view over the same files, which means I can change the view without moving or duplicating the underlying material. I did not connect all of those nodes myself. Claude added links as it worked. At first, the graph had scattered dots with a few small clusters. As more work moved through the vault, those clusters grew and started connecting across topics. An article could connect to the research behind it, the product it supports, and the decision that changed its direction. That is the behavior I wanted. Normal work keeps improving the structure, so maintaining the second brain is part of doing the work instead of a separate linking project I had to remember later. The same nodes can also become a visual map. I asked Claude to lay the MCP cluster out on a Obsidian canvas. Because the relationships were already stored in the vault, it could organize the map around a central topic, branch into themes, and place the related articles under each theme. Every title on that canvas is still a live node. I can hover to preview it or click to open it. The canvas gives me another way to move through the same connected material without creating a separate copy that will go stale. The screenshots make the system easy to show, but the change I feel is in the workday. I used to guide Claude step by step. I would point it to the file, remind it what we decided, explain how this draft connected to the last one, and then do much of that again in the next session. Now Claude can read the note, link the related work, pull an old decision back when it matters, and draft from my notes and past work. The index handles the lookup, so Claude can reach the relevant context without rereading the entire vault every time. I still decide what matters and what gets saved. The difference is that I no longer carry the location and the connection of every piece in my own head. That vault remembers that for me. That is what Obsidian gives me: local nodes that connect, a fast index over them, and a memory layer Claude can read and update as the work changes. I kept two parts out of this video: how I version and backup the vault with GitHub, and how I sync the same vault between my local machine and the cloud. Those are separate setups, and each one deserves a proper walkthrough. If you want either of those walkthroughs, let me know in the comments. The complete written build, including how I connect Claude, structure the vault, install the skills, and keep the system clean, is in my newsletter article linked below. I hope this helps you see where a connected second brain could fit into your work. If you want more videos like this, hit like and subscribe. See you next time.